Hey guys, in this video, Ian and I will be explaining the process of neutralization using the diagrams from the atom kit.
First off, what is neutralization? Neutralization is a chemical reaction between an acid and a base that produces a more neutral solution. But how can we tell that the acid and the base have created a neutral solution?
You can tell by an acid and a base creating water as the neutral solution, or in equations check if water is part of the products. Now, let us introduce the atoms we are using to perform the neutralization reaction. Sodium, or Na, is the styrofoam ball. Oxygen, or O, are the red atoms. Hydrogen, or H, are the white atoms, while chlorine, or Cl, are the green atoms.
Now that you are familiar with the atoms, here is the equation. Sodium hydroxide plus hydrogen chloride is balanced out to be sodium chloride and hydrogen dioxide, or water. Let's start breaking it down.
On the right side, we have the reactants. The two compounds we have are sodium hydroxide as the base and hydrogen chloride as the acid.
During the chemical reaction, the atoms break down and rearrange to make new compounds. When they come back together, the compounds
They come together and form the products, water or hydrogen dioxide and sodium chloride. Water is the neutral solution created by neutralization. Now for the demonstration.
Let us get started with the demonstration. We start pouring 10 milliliters of sodium hydroxide into a small beaker.
We're going to fast forward a little bit because it takes a bit of time. It's going to take a while.
You're gonna fast forward this, right?
Much faster. Now, at 10 milliliters of sodium hydroxide, we will now pour bromothymol into the beaker.
We use bromothymol as an indicator to show if the chemical compound is more acid or more base. Changing to a blue color means that the mixture is more base, and yellow if it is more acidic.
We are dropping 5 droplets of hydrogen chloride into the mixture. We keep doing this until we see a chemical change, specifically a color change.
You can see we occasionally change the number of droplets at a time to near the neutral state we are looking for. Finally, a color change. After enough hydrogen chloride that was dropped, the blue mixture has turned yellow.
This means that the mixture is now more acidic as shown on the pH scale. We continue to try and balance the hydrogen chloride with the sodium hydroxide, making the color change from blue to yellow to blue.
For it to be neutralized, it needs to have a pH level of 7, the same as water. And there, you can see that the solution has become darker green.
We show on the pH scale that it is 7.2, meaning it's slightly baser than acidic. So, we start making the amount of droplets smaller to get the neutral solution we want.
Or actually, it doesn't look that dark green.
is it yellow?
It's 6.2.
What the heck? It's so much yellow. You do this.
Another one? Or like one half?
We come to a point where we are uncertain of the location of the solution on the pH scale. So, we use more indicator or add more bromothymol to confirm the location on the pH scale.
One drop of hydrogen chloride.
That's great. There's not too much. There's too much.
Oh god.
It's too much.
One drop of
Where's Josh? Oh. Good. Oh,
that looks green.
that's green.
Greenish. It's not. Oh, actually, hold on. That looks pretty
Finally, after careful amount of droplets, we come to a neutral solution that looks like it falls in place on the pH scale with a pH rating of 7.0.
Thank you for listening to our presentation on neutralization. We hope that you understand the content well enough for Josh and me to get an A, maybe an A+.
Thank
you very much.